Good morning. Well, I'm not doing this on Periscope. This is going to be quite a long video. I will try and keep it as brief as I can today. Thank you. And, but I want to go through the entire climate change, climate hoax, climate catastrophe, global warming, global cooling, call it what you will. I want to go through this. I've done sort of videos before on some of the aspects of this, but I'm going to try and join it all together. I've done videos on simulations and what I know about simulations and how that goes into the science. I want to talk a little bit about the constituents of the atmosphere, but I don't want to go into the specific climate science details. I've looked at some of them. I'm going to explain to you my credentials because, unfortunately, even though Nicholas Taleb is right, Nassim Taleb, credentialism is a complete disaster. And the problem with credentialism is the idea that the only people you can listen to are people who have had an academic background. Well, I actually do have an academic background, but not in climate science. I'll explain that. So who am I? I'm Brian of London. If you watch my videos all the time, you'll know I do regular videos from here in the park in Tel Aviv, actually, Bereshit Forest in the middle of Tel Aviv. And the main thrust of what I talk about Israel, I talk about stuff online, tech, but I was once a PhD physicist. I achieved a PhD in computational physics. So what I did was for 3 or 4 years, 3 years I wrote the software, another year to write the thesis, handed it in, defended it, got my PhD. So I am Dr. Brian of London. With another name, anybody who wants can direct message me and I'll show you links to my papers. My name is out there now. And what I did was I spent 3 years plus a year of writing to study how plastics flow when they're liquid. See this plastic cup? It's made of, I don't know, LDPE or HDPE, linear low density polyethylene or high density polyethylene or some other plastic. I studied the theory behind what happens when you're making this cup. And when you're making this cup, you melt the plastic down, you push it through a bunch of machines and you blow a bubble, and then you clamp the bubble in a mold and out of the bottom drops your plastic item. That's how the vast majority of stuff like this is made. And it turns out that the vast cost of making this, there's two costs. There's the raw material, which is polyethylene, which comes from big industrial petrochemical plants, which come eventually back to crude oil. So they take the crude oil out of the ground, they split it up, they give you some petrol, they give you some diesel, and they give you some jet fuel, and they also give you the raw material of this in big bags of white, sort of, not powder, but pellets. And you put it in your machine, you melt it down. Now, the energy used to make the plastic cups is actually by far and away one of the biggest costs. And that's what I studied, was how the stuff flows in a very theoretical sense. Because what I did is I wrote a computer simulation. And a computer simulation to predict how changes to the molecular structure, not the chemical nature, so it'd be the same polyethylene, but you just change the shape of the molecule. So instead of it being a straight molecule, you have little branches on it. How does that change the way it flows? Well, it does. And my PhD thesis was an absolutely novel way of calculating the flows of liquid plastics that had never been done before. So there was a whole 40-odd year history of using computers to predict the flow of plastics. And what they had done was they'd taken the same equations as water or gases, the same sort of simulations that by the mid-90s were absolutely commonplace. You could simulate the flow of air over a wing. You could simulate the flow of water around the hull of a ship. You could do those jobs very, very well, get very accurate results, and if you designed your little aeroplane in your simulation, and then you built it, and then you flew it, perfect agreement. And same with boats. But when you use those same equations and those same calculating methods, no matter how many ways you fudged the equations and added viscosity and all sorts of other kind of weird tricks, plastic didn't flow like water. And you'll know this from your real world, because plastic actually flows like honey. Honey is the same kind of fluid that this plastic is when it's molten. And honey does something very strange, which you'll all know, which is called, when you stir honey, instead of it being pushed away, like if you stir tea, the tea moves to the side of the cup and there's a hole in the middle where you're stirring. If you stir honey, what does it do? It climbs the rod. It goes the opposite direction. You can't use the same equations for modeling honey as you can for water. But yet that's what scientists for 40 years were doing. And they wrote paper after paper after paper saying that if we change this little bit here and we add this little feature here and we add that, none of it worked. My boss came up with an idea to do a totally different method of simulation, and we did it. And I wrote the computer code. It was, for a physicist, it was a very much more sophisticated computer code than most physicists at the time would have been happy doing. And that's because before I did my PhD, I did a Bachelor of Science, and I did physics and computer science. So anyway, what happened at the end of my 4 years of studying? I went and presented my PhD to a room full of people who were all in the field that I was in, molecular rheology, studying these flows. And at the end, the smart ones in the room realized that I had just overturned 40 years of scientific consensus. That it just was a fact. They realized very quickly that all of the ways that they were calculating their calculations and making their predictions were just fundamentally wrong, because the method of running the simulations and the equations they were putting into the simulations combined would never work. And what I did, which involved the history of the flows, I won't go into the detail, it changed the whole field. So that's my scientific credentials. I can read scientific papers. I'm comfortable with that. I don't do it for fun. I left the field soon after that. And I've always said that getting a PhD means you are the world's leading expert in the world's smallest subject for about 6 weeks. If you stay in the field and you keep working and you keep reading papers and you keep writing papers, you'll maintain your position as master of your field. But I left and went off into business and did other things because I didn't like the way science was funded. So when I come now to look at this whole field of climate change and the impending climate catastrophe that we've all been led to believe is going to befall us, I look at all of the science underlying it, and it all stems back to the kinds of simulations that I worked on for 3 years. And when I say simulations, my simulation was a very theoretical version of a plastic. The molecule was pure and obeyed some unbelievably constrained physics that we put into the model. And it was small. It was like a 4 centimeter to 1 centimeter contraction. That's what I was simulating. And I was looking 4 minutes into the future. So everything was tightly controlled. I knew everything about this very theoretical, and I was doing it in actually in 2 dimensions. I wasn't even in 3 dimensions. 3 dimensions. And then to make it even easier, there was a symmetry line down the middle. So I was actually only doing half and then sort of flip it, all to reduce the calculation costs. And I was running on what was then a £20,000 silicon graphics workstation. Actually, this phone is much more powerful now than that £20,000 silicon graphics workstation like the one they did Jurassic Park on, but that was the best we had. So when I look now, and they've been making these climate predictions based on these models for 30, 40 years, and I look around at the climate and the scale of the problem that these people are trying to address, and I know that it is bullshit, that the entire science of modeling the future out to 100 years or 200 years or 1,000, it's just nonsense. It can't be done with any capability that man has developed so far. More than that, I knew the physics of everything going on in my tiny little system. Now, it matched observations better than anything else, but it wasn't perfect because we threw out so much real detail. These guys don't know. They're guessing. They're still guessing. After all these years, they've come up with a theory called the greenhouse gas theory. Now, my position, just to sort of jump in now with what do I think is going on, the number one answer is we don't know. The number two answer is the climate is always changing. It has always been changing, and it will always continue to change. And the changes that are going to keep happening are perhaps some might be attributable to man's actions. In the end, and we'll get onto this because I'm actually going to talk a little bit about what CO2 is. In the end, my fundamental belief, though, and it is a belief, is that we're not smart enough to know what we did, what effect it's having, and more importantly, we have absolutely no idea to reverse something that we're not sure of in the first place. So let's just actually, what is the atmosphere? What is this CO2 thing? So the atmosphere around us is 78% nitrogen. You don't really need to think about nitrogen. It's important to the plants when it comes in as fertilizer in their roots, but largely it does nothing. It's what you take out of the air and pump into packaged food in order for them not to do anything, because nothing lives in nitrogen. So it's a good way of preserving stuff. It's also really useful, as I know from the physics department, for if you have a compressor and a cooler, you can suck nitrogen out of the air, cool it down, and you get liquid nitrogen. And if you add that to cream, along with perhaps fresh strawberries, you get the most amazing ice cream in about 30 seconds. It's wonderful ice cream. You don't need so much sugar. That's nitrogen, 78% of the oxygen. Let me just say it another way. Not only is it 78% of the atmosphere, it is 780,000 parts per million of the atmosphere. That'll be important. You'll understand why in a minute. Next on the list is 21% or 20.9 something percent of the atmosphere is oxygen. That's what we breathe. It's not only important for breathing because it's important for burning stuff. Whenever we burn stuff, you need oxygen. That's why you can't burn stuff in space. You need to add the oxygen. That's why rockets bring their own oxygen. And that oxygen, obviously, it's 21% of the atmosphere. Let me put that another way. 210,000 parts per million of the atmosphere is oxygen. Next, we have something called argon. It is utterly unimportant as to what argon is or why it's there, but 1% of the atmosphere, or just under 1%, is argon. Finally, after we're down to 1%, so 78, 21, 1%, the next one we get to is this carbon dioxide stuff. Carbon dioxide, as I remember from a few years ago, if it reached what was called 400, if we get carbon dioxide at 400, there will be a tipping point, and that'll be the end of the world as we know it. Well, a few years ago, carbon dioxide, which, by the way, is measured on an island in Hawaii. I've never really fully understood why there's only one measurement place for carbon dioxide, but that's the one place, and it goes up and down throughout the year, actually. But let's, for the sake of argument, we'll say that 400 and something parts per million. But why do they keep talking about parts per million? Because, like I said, nitrogen is 780,000 parts per million. So when you got 400 and something parts per million of carbon dioxide, it doesn't. And the thing is, if they had to actually say it was 0.04%, that's the thing. Now, carbon dioxide is what the plants bring in. They put out, when they're photosynthesizing, they need carbon dioxide. So if you were growing up like me and you know what a greenhouse is where you plant plants. And what do? You put a lid on where the plants are. Today, they don't even use greenhouses so much. They put these polythene tunnels on. It achieves the same thing. What does it do? It gives you a higher concentration of carbon dioxide around the plant. What does that do? It makes it grow faster. And in fact, the world has been experiencing something called global greening for years, which is that farmers are getting much more yield out of their crops than ever before. One of the advantages of climate change, perhaps. Now, without going into the details, there are so many different theories for what influences this giant system around us that is on a scale that I can't even begin. As a computer modeler, okay, computer simulations. Let me just explain to you what those are. I've done this in a separate video, but let's bring it all in one place, and then I'll tie it all together with a bow at the end. What's the best example of a computer simulation that you use in your daily life? My favorite example is Waze, the traffic navigation app. So you get in your car and you open Waze, Israeli invention, bought by Google for $1 billion, still run out of an office in downtown Tel Aviv. What do you do with Waze? You say, go to my office. You know how to get to your office, but why are you using Waze? You're using Waze because Waze does something more than tell you how to get places. It takes information from all of the phones of the other people using Waze, and it creates a dynamic map of where all the cars are, where they've stopped, where there's traffic, where there have been accidents, where there are potholes, where there are police. It brings all of that information in. Genius idea. And so what does that do? It then, when you say, I want to go to my office, what Waze does is a simulation. It says, these are 3 or 4 different ways that he could drive to his office. He could go on the big motorway, or he could go on the back roads. And I'm going to work out right now, based on the speeds of the cars moving on all those roads and all of those segments of roads, I'm going to work out how many minutes it will take right now to get to the office if the traffic conditions that I can see right now stay the same. And it says 22 minutes if you go on the motorway, or 17 minutes if you go on the back roads. So you set off. And if you're following the Waze simulation, you say, in my future, in 17 minutes, I'll be at my office. Whereas if I went this other way or took these other actions, it would take a little bit longer, but you trust the Waze. Now, Waze is a fantastically great simulation, and it is very good at predicting your time of arrival because the system that it's working in is well known. You can't drive off the roads. You're going to stay on the roads. You can't fly. You can only drive between this speed and that speed. You can't suddenly do 400 miles an hour. All of those different things, all of those breaking of physical constraints would make Waze's prediction less accurate, but your system is pretty good. Now, what Waze can't predict is if some Israeli nutter just in front of you smashes into the back of the guy in front, and instead of pulling over to the side of the road, he just stops his car there and starts to have a massive argument with the guy who he just ran into, claiming that it was his fault. And you're stuck behind this accident that has suddenly appeared right in front of you. When you asked Waze 5 minutes earlier for how long it was going to take to the office, Waze could not predict that. And the reason why Waze is such a good simulation is because it's a very tightly bounded simulation. We understand the physics, we understand driving, we understand roads, we understand the rain. We know we can make allowances for all of this stuff. We do not know how the sun interacts with the atmosphere. We've got tons of theories. We test them, we check them, they get overturned, the new theories arrive. We have no idea what's going on with the oceans. We have no idea about the interplay between the surface temperature of the ocean. We don't even know how to measure temperature of the world. We have no idea. The surface temperature of the sea varies massively. I live in Israel, in the Mediterranean Sea in February is cold, really cold. You get in and you shiver and you have to wear a wetsuit. By the end of summer right now, I get in the sea, it's like a bath here. So there's this massive, 10, 12, 15 degree difference between winter and summer of the sea. So if you're telling me that there's a perturbation on the sea surface temperature of 1/3 of a degree in the next 20 years, how the hell are you going to measure that amongst that noise? How are you going to measure? Measuring temperatures is notoriously difficult because of something actually called the urban heat island effect, where it's hotter in cities. There's more people, there's more devices, more air conditioners, more cars. All of this stuff actually raises the local temperature. So if 150 years ago somebody set up a nice little measuring station in some deserted part of Israel called Ramat Sharon, where there's lots of strawberry fields, and they've been measuring the temperature there. This is true. There's a place called Kfar HaYarok right next to me. There's a weather monitoring station. When I moved to Israel, I moved into a new building. It was built 12 years ago or so. I moved in 10 years ago. And since I've lived there, all around me, buildings have started to go up. We're inching closer to the temperature measurement point at Kfar HaYarok. They measured temperatures there 70 years ago at the foundation of Israel. But today, instead of Kfar HaYarok being in a nice sort of open, non-urban area, it's suddenly being surrounded by Tel Aviv to the south and Ramat Sharon to the north. The whole area is changing. That changes the temperature. So every time somebody tells you that the temperature's gone up, they've had to readjust all of the stations for this urban heat island effect, which we're studying. We don't know what the difference is. Now, all this is to say that when it comes to Greta Thunberg and the climate catastrophe people, my attitude to this is they are nearly always coming with an answer that looks to me very much like socialism or communism, or worse, back to somebody called Malthus, who predicted the end of everything. He's always predicting the end of everything. Population explosion, nobody would have food, all of this stuff. These people are always coming with the same story of global catastrophe. And these global catastrophes don't occur generally. And we've got healthier and wealthier, and we're all living better than we were. And global poverty is declining, and global hunger is declining. Why? Because mankind's actually really good at solving problems. Really good. Israel's a perfect example. We have so many more people in Israel now, today. You know, it was 200,000 or 300,000 at the turn of the 19th century. And today we're 9 million people here. It's not possible for turn of the century Israel to have supported the people who are here now, but we are supported very nicely. We've got water. There's a nice clean glass of water. This water may have come from the sea, or it may have come from the Sea of Galilee. And when I say the sea, it might have been turned from seawater into fresh water by desalination with energy. We solve problems. What we can't do, though, is believe that some kind of trick of decarbonizing. What's decarbon? This carbon dioxide thing. Why is that the only thing these people are fixated on? I think it's because it's the only message they thought was simple enough for stupid people to grasp. I'm not saying you're stupid if you believe them, but I'm saying that they've dumbed it down to a point, and they don't even talk about carbon dioxide anymore, if you notice. They talk about carbon neutral. Everything's made of I'm made of carbon. Every single living thing is carbon-based. We are all carbon-based life forms. They reduced this. They reduced our entire world's problem to the emission of one gas, CO2. Why is that so important? It isn't. If we wanted to solve that and continue our lifestyle and have energy, my bet would be on nuclear. What's the problem with nuclear? Well, Chernobyl for one. And what was the problem with Chernobyl? Having watched the TV show obsessively and read much more than that, to be honest, the big problem with Chernobyl was it was built by communists and run by communists. And that system leads to human disaster. And what are they planning to replace our global economy with? To one that they say will produce a more carbon neutral, a better way of living? Well, it looks damn well like communism to me again. Central planning. You can't do this. You can't fly on that aeroplane. No, it's wrong. Now, I am healthily worried by local pollution. That's why I drove an electric car for 5 years in Israel. I don't like local pollution. And we know a lot about local pollution from Israel because one day a year, which is a day that's coming up soon, we're heading into Rosh Hashanah. Right after Rosh Hashanah is Yom Kippur, the Jewish Day of Atonement. I've written about this. This is a day where even non-religious Jews stop driving. All industry shuts down, airplanes shut down. We actually block airplanes from flying through Israeli airspace for the day. And they've done amazing studies here showing that within a couple of hours of the start of Yom Kippur, when motor traffic drops to almost zero, almost all ground level local pollution just dissipates. We go back to unbelievably clean air, and it happens fast. And by the end of 8 or 12 hours, we've got clean air again. Which is to say that if we did stop driving all our cars, or we did switch to, let's say, nuclear energy generated electricity powering electric powered cars, the quality of our air would increase dramatically. I don't give a damn about carbon dioxide. That's relatively unimportant. As far as I can see, it might well be that we can thrive, and humans can thrive, and animals can thrive better on this planet with more carbon dioxide. Maybe the correct thing right now to be doing would be to be pumping excess CO2 into the atmosphere. We just don't know. The idea that reducing the rate at which we put carbon dioxide into the atmosphere is going to solve something is based on exactly those same crazy simulations by crazy people who have never predicted anything right, because, 30 years ago they were predicting, 40 years ago they were predicting global cooling and the climate and, the next ice age. Now it went to global warming, and then they realized now we're looking a bit silly because we don't actually know what we're predicting, so we'll just call it climate catastrophe or climate change. They predict rising sea levels. It's hard to see, and rich people are still buying lots of seafront property, which you really wouldn't be buying if you believed all of the climate catastrophe predictions. I'm not saying to be wasteful. I don't like wasteful use of plastics. I like reuse of plastics. My PhD did teach me about the energy problem with recycling. Recycling is very marginal. Reuse, so reusing a plastic bottle a few times, that's much better than recycling it. I don't like pumping sooty diesel fumes into the air where my kids are breathing. I don't like that. I drive a hybrid car because I like that when I'm doing slow stuff in towns, often it's running on the electric battery. I would drive an electric car here if I could, but the infrastructure collapsed and it's not a practical for my lifestyle. But I like the idea of not emitting pollution, real pollution, not carbon dioxide, real pollution, bad nitrous gases, bad carbon monoxide, those gases. I don't like polluting those. We should be cutting back on those, but not with a distorted central planning approach. Remember Solyndra? Remember when America said it was going to pump money into solar power and they pumped billions of dollars into this stupid company that was just destroyed by the Chinese. Why? Because the Chinese distort everything. They also pumped billions of dollars into their solar panel industry, and they won, and Solyndra lost, and the US taxpayer lost tons of money, because every time you try and pervert these markets with these crazy ideas, you're going to lose. So what have I said to you? I'll just sum up here. 1, scientific consensus means nothing. I destroyed a scientific consensus. Little me. It's not Nobel Prize winning stuff, I can assure you, but it did change the way everybody from then on had to think about the problem that they've been thinking about. So the entire field of climate modeling, I believe, is fundamentally based on just something that humans are not equipped yet to calculate. We don't have the power. We have neither the full grounding in how the systems themselves work, the interactions, how the sun works, how the sun affects the atmosphere. We don't know any of those details at the level that you need to in order to make long-term predictions. We don't know enough about all of the feedback systems that are going on in the Earth. We don't understand how, when, if some glaciers melt, what that does to the oceans. We don't understand any of the sort of gaseous interactions that are going on all of the time in the atmosphere above us. Perhaps if more CO2 is there, the plants absorb more of it. We don't know. So when you can't even accurately always predict the path of a hurricane in the next week, predicting the course of a hurricane is not a very different scientific challenge to predicting the climate in hundreds of years' time, but it's just a much bigger scale. Every time you step forward in time a little bit more, any mistake you made back in the past is going to be multiplied out to the future. I knew this from looking 4 or 5 minutes into the future with my little simulation back when I was doing my PhD. So the point here is not to get tied up thinking you're not smart enough to understand the underlying science. Neither are the scientists. They're learning it. They're making it up as they go along. And they might get stuff right and they might get stuff wrong. But putting it all together in a big bucket and saying we can simulate this, that is a fallacy. That is a fallacy. And you all know this. You all know that artificial intelligence doesn't deliver what they say it can deliver. It can't police the internet. It can't understand jokes. It can't tell the difference between sarcasm and these are all failures of massive computer models that we're building. Computer models are good for one thing, for a few things. They're very, very good for predicting the traffic, for predicting what time you'll get to your office if you use Waze. But they're not good at predicting where the accidents are going to be, where the changes are going to happen in the system. And they only work if you understand the underlying physical nature of what you're modeling. How fast cars go, how far the roads are, what routes you can take. Don't worry. And this last bit, perhaps someone will cut this and show this to children. Human beings have adapted to their environments ever since we've been on this planet. We've moved around. We started off in Africa. We spread out all over the world. We went from hot places to cold places. We worked out how to kill animals and take their fur. We didn't grow the fur. We just put their fur on. Sorry, animals. We worked out how to live more comfortably in Israel by inventing air conditioning and by generating enough water, by desalination. We can solve environmental problems. We can feed the world, even if we continue to breed at an astonishing rate. We are amazingly adaptable if we adapt. We are brilliant thinkers, brilliant at technology, at inventing technology to both make our lives possible and better. We can solve any problem that the planet can throw at us. We probably can't solve an asteroid impacting us that wiped out the dinosaurs, but we might, in a few years, if we keep working on space research, maybe even that we can solve. But small incremental changes to climate, we will deal with perfectly well. We will, if we have good governance. And good governance, the best governance systems that we've invented so far are freedom, allowing humans to thrive, efficient use of capital, markets, all of the stuff that Greta Thunberg has been taught to say she hates, like capitalism, which is not a great word, but we'll use it. And all of the systems that back climate change, Green New Deal, they all come from a centrally planned, globalist, communist, socialist background that leads to human stagnation and eventually depression and downing. That's what we have to avoid. The climate isn't going to kill us, but globalists, communists, and destroying human ingenuity, that can kill us. So look out for this. Anytime somebody's trying to sell you this climate catastrophe hoax, and what they're really saying is, we central planners need control of everything. We need to say how power will be generated, not a market. We need to boost wind power or boost solar, not a market. We need to ban nuclear because we think it's scary. Anytime somebody comes up with that kind of stuff, that's when you need to be suspicious. What will beat it is ingenuity, new solutions, new tech, new ideas, new ways of thinking, not trying to obsess over some gas, carbon dioxide, that amounts to imagine 1 million M&Ms, and 400 of those are the problem. It's nonsense. It just doesn't make sense. It doesn't make sense. This is Brian of London. If you've derived any value from this, check out my website. Maybe throw me some value. Like me on 3Speak Online, which will give me some cryptocurrency, or send me some money on Fundition or Subscribe Star. because it's nice to feel appreciated. I hope this has done something for someone. It's quite long. I got interrupted a few times, but Brian of London in the park in Tel Aviv, wishing you all Shana Tova, Shabbat Shalom for tonight, and have a great new year, because it's the Jewish New Year coming up. Bye.